Go over some memory today. This will be similar to the CPU video that we made about really trying to explain to you what the difference is between the different types of memory. And when you look at buying some memory, there's going to be all sorts of numbers and this is expensive memory because of this, and this is expensive memory because of this, and we're really looking more at informing you as to what all of these numbers mean. And if we start with this, our standard types of RAM, you're not going to see so much of the lower ones anymore, but SDRAM, DDR-RAM, DDR2, DDR3. SODIMM is not a type of memory, it's a type of package. What this stands for is Small Outline Dual Inline Memory Module. These other ones will be called DIMMs. They'll be the full-size ones. The small outline ones are going to be laptop memory. They use the exact same technology, but they're using some lower voltage parts, maybe parts that are a little more withstanding to being grouped together in a smaller package so they don't overheat. A couple of the differences between the different types of memory. RAM operates on a sine wave, which is the wave that goes up. It has a hill, and it has a trough, and it has a hill and a trough, and sound travels in a sine wave, and a lot of your electricity does too. But anyhow, for SDRAM, it picks up memory when it goes up. So it goes up, picks up memory, comes down, comes back up, picks up new memory. So it was only accessing memory on every upstroke. DDR-RAM was getting memory going up and coming down. Going up and coming down, so it'd get two pieces every cycle. Part of the problem you run into with these things, you might have heard of people overclocking their memory or faster memory, or you get memory that's unstable. And what unstable memory is memory that has either been damaged or has been run out of spec or is not rated for the correct speed, or maybe your motherboard doesn't see it as the correct unit and it's running it too fast. Usually you don't have that problem. They like to all default to run them too slow nowadays. But what'll happen is, because the sine waves going up and down, the faster the RAM is running, the closer these sine waves are to each other. And if you think of when it picks up the data, if you think of it like a circle going up this wave. So you got the wave, you get your circle, and the wave gets closer and closer together, and eventually the circles start touching, and you end up with corrupted data. So this will cause problems, blue screens. Maybe you have damaged RAM, maybe you're actually losing signal as you're going through the RAM module, and that will cause it to fail. Now, memory works by storing a 1 or a 0, and how it does it doesn't actually have a way to do this without power, and it has to be refreshed every so often. So that's what the sine wave is doing. It's going through and adding power to a capacitor, and if you shut your power off on your computer, all the data that's currently in RAM is lost. So that's why when the power goes out and you were working on something and you forgot to save and it's all gone, it's because all the power went out of the memory and you have lost everything that was there. The higher levels, DDR2 and DDR3, don't actually have any more signals per clock. Like, they still only get one going up and one going down the wave, but they have some other technologies to basically increase the amount of waves that can be picked up or used concurrently. So they're a little more parallel in design. That's where they get their superior bandwidth, because the actual speed of these memory modules really hasn't changed much since the DDR days. They've gotten a little bit faster, but they've pretty much remained right around where they were back then. How single and dual channel work? I mean, this was a lot more back on like the Athlon 64 days, but you'll still hear dual and now even triple channel memory if you're looking at some of the newer Intel machines. Each memory module has a 64-bit data path, so it's 64 bits wide. Servers have 72 bits because they have what's called ECC RAM, or fully buffered RAM. It has error checking to make sure they don't lose anything, because you don't want to corrupt your server data, because that could be bad. Dual channel puts both the 64-bit paths together, and it makes a single 128-bit path. It basically uses 2 sticks of RAM as a single giant stick of memory, and there's a lot less overhead, and it equates to about a 10% performance boost, depending on how memory starved your application is. If your application's completely bound by memory, it's going to see the full benefit. If it's waiting on your processor and there's memory to spare, you're probably not going to see much of anything. Maybe a little bit of a latency decrease. If you look at the generations themselves, when DDR2 first came out, it was you'd see like DDR2 4200, and then you saw 5300. And DDR 4200 is DDR2 PC4, or it's PC 4200 DDR2 400, and then there was also DDR1 400. The DDR1 400 is actually clock speed for the memory module equivalent to about DDR2 800, and what you would see is the higher performing old generation chips are a little better in bandwidth than the low-speed current generation chips. So, I mean, if you went out and shelled out for massively fast, large amounts of RAM with your previous generation, don't go rushing just to upgrade to like a lower mid-range part of your current generation. You're going to have to go and get something mid or high to really see a performance increase. You're going to see more of a reason to change out based on like the architectures that support it, because like the new Core i series doesn't support DDR2, it's all DDR3. You can still run some DDR2 on your AMD systems, like I'm currently running. I have 4 gigs of DDR2 at home, and they're 1066. I mean, there was a little bit faster, but I mean, unless I wanted to go out and buy like some good DDR3 1600, you're not going to see much of a performance increase on the 1333. Memory timings are what you're going to see when you go to actually buy a RAM. I mean, if you go into a big box store, the memory is really not going to have too much as far as timings listed. They're just going to have the cheap stuff, so they fill their shelves with it. But if you go to a PC specialty shop or like an online store and you're actually looking at RAM, you'll see lower priced RAM, higher priced RAM, ones with different amounts of latency, and lower latency is faster, higher latency is slower, and the price usually varies accordingly. If you're actually running memory, you're overclocking a little bit and you're running out of spec. If you had to increase your timings to make the RAM run stable, you may have actually lost performance, because slower memory with a lower latency can actually be faster than faster memory with a higher latency. And that has to do with like responsiveness of the PC and how long it takes to compute things. CAS latency is the processor says, hey, I need something from this, and it goes to the RAM, and it's how long the RAM takes to respond. It'd basically be the equivalent of how long it takes to wake someone up from deep sleep. You say, hey, you gotta go to work, and you shake them. How long do they take? Some people get right up, some people are up before their alarm clock, and some people don't wake up very well, and you gotta bang on things and make noise. The RAS to CAS delay, it's the activation of the line and column where the data is stored. If you think of memory like a matrix, like it's laid out in rows and columns, in order to find an individual row and column, it will go over in rows and then drop into the column. So it's how long it takes between when it activates and when it's kicking back out. So how long does it take to turn on and then kick memory back out? The RAS precharge is when you turn on that line after the TRCD, the RAS to CAS delay, that one, when you turn on that line, how long does it take to turn off that line and turn on the next line? So you grabbed a piece of memory, and now you got to grab another piece of memory. How long does it take to switch between those inside? And after that happens, when you make an access, the TRAS is how long can you wait until the next access for the memory can be started. So like you get it, you retrieve the memory, how long does it take for the charge to clear so you can start up another one? The command rate is, as it says, the time between the memory chip having been activated when the first command may be sent to the memory. remember the CAS latency is how long it takes for it to respond with a command. The latency actually is also like how long it takes to respond. The command rate is it sends a command to turn the RAM on. When is the RAM actually ready to take orders? Basically, remember the analogy with the sleepy guy earlier. When you wake up, sometimes you're not really ready to work right away. You're stumbling into things and you can't see things. The command rate is how much of a clock cycle delay is there between the RAM being on and the RAM really working. Some of your memory controllers, especially the cheaper ones, can't handle the T1, so they're almost all set to T2. If it can handle T1, there's actually quite a decent performance increase there, especially in like the responsiveness of the machine. Also, something to note when this is going on is with memory, if you are buying memory that's like DDR2 1066 or 1200 it's rated for, or higher end DDR3 like the 2000s, essentially what memory is like back before memory, it was really incompatible with things like this only takes SD 133, this only takes DDR 333, this only takes this only takes this, or slower. Pretty much what they've done now is RAM is being binned in a way that it's rated for the highest amount that it can physically run at a safe voltage. Safe voltage is like 2.1, 2.2 volts for DDR2. I'm not really certain on the DDR3 voltages because I haven't really worked with it yet. But like I have DDR2 1066, and when I put it in my machine, it shows up as DDR2 800. Why does it do it like this? Because the standard is 1.8 volts, and pretty much every motherboard out there is going to run it at 1.8 volts at DDR2 800 speeds. Some motherboards can't handle running it at 2.1 or 2.2 at DDR2 1066, so it defaults back to this safer area. And there's usually guides on their individual websites and forums as to how to set the memory to its correct rate that you bought it for. Sometimes maybe you only want to run it at the speed that the motherboard's running at. You can probably go in and make some changes to these settings and speed it up. But it's more it's if you get one wrong, it'll get unstable and it'll crash. I mean, you probably won't do much damage to the PC unless you're shoving voltage at something. That's kind of how most of the stuff works. You might have to reset the CMOS to get the BIOS back, but I mean, you can play with these without too much danger of actually hurting the machine, as long as you're not pushing more voltage than like the rated amount. As far as further reading on this subject, if this really interested you and the like the technology behind it, if you go to Google and type in the secrets of memory BitTech, a man named Ryan Lang approached BitTech, which is a hardware review site, and basically they published a paper that he wrote on memory and memory technologies. And I read it a couple of months ago, and it is, I mean, even though it was written back in 2007, the paper is amazing. I mean, I think my head actually hurt after I read some of that, and I actually had felt that I really had really learned something from it. And it was a very good read. There's 4 parts of it. It's